chaplain for 14 years. He was a past candidate in 3 federal elections for the Green Party, and he's a member of Climate Action Sarnia Lambton. And he hopes this speaker series provides an opportunity to reach out to the wider community and inspire more people to join us. So without further ado, we'll let Allan give his presentation on the Virosphere.
Thank you very much, Paul. Good evening, everyone. All can hear me, I hope. Yeah, so I see a few familiar faces out there, some from my old lab days, so great to see you all. Thank you all for joining me and Climate Action Sarnia Lambton this evening for a glimpse into the Varasphere, the world of viruses, the most abundant life form on Earth. Perhaps you didn't know that viruses are the most abundant life form on Earth. So I will share with you some things tonight that may also surprise you, maybe even amaze you. But first of all, I just want to make it clear that, you know, I don't come here as an expert. I retired in 2003 to do other things. I never would have thought that years later that I would be doing a presentation on viruses. But the last couple of decades have revealed so much about them. Scientists have been able to break open viruses for the very first time and study the genes inside, what makes them tick. I'm sure you've all heard of the expression sequencing the genome. So, and this has revealed a vast amount of new knowledge and understanding. So I want to assure you that everything I share tonight has been carefully fact-checked. The World Health Organization has warned that we are in the middle of two pandemics. The second one they call the infodemic. It's a tsunami of misinformation about viruses, about the coronavirus, and about COVID-19. Much of it we're exposed to on the internet. Much of it is misleading, and some of it is dangerous. So let me just say there are millions of different viruses, but there's actually less than 300 that are known to infect humans. However, having said that, there's an estimated 500,000 viruses with the potential to jump from animals or insects into humans. So where will the next pandemic come from? So tonight we'll take a journey into the Varasphere, and hopefully by the end of my presentation you'll have a better understanding of viruses and also why pandemics happen and maybe what we need to do to minimize the risk of the next one. So lots of information to share. I'll start screen sharing my presentation. And hopefully there's no virus in the computer here that's going to mess things up. So welcome to the Varasphere. Hopefully you can all see that. This is a highly magnified image of a virus attached to a human cell. It's colorized so you can see the difference. The orange things are the viruses. And they're doing what every virus does to survive. It's trying to break into a cell in order to instruct the cell to make copies of the virus, and then it can transmit itself once the cell dies and the viruses are released. So the virus is either drilling through the cell wall to inject its DNA into the cell, or very often also what happens is that the cell will mistake the virus for something that's beneficial to it, such as an essential nutrient. And the cell will actually open up its cell wall and bring the virus into the inside of the cell. That's a process known as endocytosis. So as I said, once the virus is inside the cell, it takes over the cell's nucleus and directs it to start making copies of the virus's proteins, which are then assembled into new viruses. So if you think this is a strange looking virus, viruses come in all kinds of shapes and sizes. They're all very, very small, of course, but there's a lot of diversity in shape, and this is actually the Ebola virus. This is the Ebola virus, which has an 80% mortality, and I think you're all familiar with that. It has caused a number of outbreaks, especially in Africa. And there's actually an outbreak right now in Guinea. And there's been a number of outbreaks in the last 5-6 years in the Democratic Republic of Congo. Canada actually developed a vaccine against Ebola, so it's now being used in Africa. But the challenge is getting it out there into the people's arms, which can be challenging. So Ebola is an example of an emerging infectious disease, and there have been 88 emerging infectious diseases since 1980. So these are zoonotic diseases, meaning they're transmitted from animals into humans, or vector-borne, meaning that they're transmitted by mosquitoes or ticks or other insects. So the definition of an emerging infectious disease is a new disease which we have never known existed before that is now causing havoc in humans, or a disease that has been of very, very low incidence and is now becoming much more prevalent. So that's an emerging infectious disease. The thing about these new viruses that are coming along, such as the coronavirus, they're not seeking us out. They're not malevolent. They're not trying to kill us. We actually make it easy for them to invade our bodies. We create the conditions for new diseases to emerge. So if we weren't doing some of the things we're doing, we wouldn't have to worry about so many of these emerging diseases. But certainly since 1980, there's been a lot of them that have come along. The population of the world now is approaching 8 billion, and that's a lot of people. So we're going into areas that we never have gone into before, and we're being exposed to these new diseases. So this is a petri dish of various animals that can harbor zoonotic diseases. You have pigs and camels and bats and civet cats, rodents. All these can carry viruses which have the potential to jump into humans. So let's look at the 3 SARS viruses which have come along since 2000. I was still working at the hospital when the first SARS outbreak came along, severe acute respiratory syndrome, coronavirus 1, which had a mortality rate of 10%. But it killed 44 Canadians and less than 1,000 people in total in the countries where the first SARS was found, where it caused problems. So although it didn't infect a lot of people, only 44 Canadians died. It was a new disease. We all panicked. We were all afraid of it coming to the hospital in Sarnia, to the community. And rightly so, because it did have a very high mortality rate, 10%. But it didn't cause a lot of deaths because it wasn't highly transmissible. We learned that healthcare workers in close proximity to patients needed to wear N95 masks, that people needed to be in close contact in order to get the disease. And by wearing N95 masks, that would give you good protection. That took a little while to learn, just as we're learning about this new virus. The second one was Middle East Respiratory Syndrome, which came along in 2012. And it had an even higher mortality rate of 33%. 1 in 3 people who got this coronavirus died. But it was only found in Saudi Arabia and a few other Middle East countries. People got infected from camels who acquired the virus from bats, probably African bats that infected camels. So the one we're dealing with now is the 3rd coronavirus in the last 20 years, SARS SARS-CoV-2. And it has the lowest mortality rate. In the first wave in the spring, the UK estimated that the mortality rate was 0.8%. But even with a low mortality rate, it killed tens of thousands of people. And as you know, it's killed many, many thousands, hundreds of thousands. Is it over 2 million now around the world? So why, with such a low mortality rate, has it killed so many people? It's very simple, because this virus is highly transmissible. So it's unlike the other two SARS viruses, this one can spread very easily. And not only can it spread very easily, it can cause asymptomatic spread and pre-symptomatic spread. So a lot of people who get infected are getting infected from people who don't know they're infected. And that's why we need to wear masks and practice social distancing. Now, as you can see at the bottom, there's a lot of other common cold coronaviruses. They're not well studied, but there's 4 of them there. They're giving letters and numbers, and they're usually non-fatal. They actually cause about 25% of all colds. So children, when they pick up colds, and they tend to get a lot of colds, about 25% of them will be caused by coronaviruses. And so maybe that is why children aren't getting very seriously ill. At least the majority of children are not getting very seriously ill with COVID-19, because they may have possibly some cross immunity from these common cold coronaviruses. The one here, OC43, scientists reckon that it actually caused a pandemic in 1889. In 1889, there was a flu pandemic that was called the Russian flu. But scientists have looked back now, and they see great similarities between that pandemic and this current one. And they think that the 1889 Russian flu was actually a coronavirus pandemic. There was only 1.5 billion people on the planet back then, but it still managed to kill over 1 million people, including quite a few Canadians. So I just wanted to throw in this little slide here. You know, when you get on an airplane, the cabin crew go through the safety instructions. And one of them is, of course, they say if there's a drop in oxygen or in air pressure, the oxygen mask will drop down. And they always emphasize that it's important that you put your own oxygen mask on first before helping others, so you don't pass out. So I just wanted to include this just because this is a terrible pandemic. Everyone's suffering, and some people are suffering horribly, losing jobs and all the rest of it. Everyone's under a lot of stress. So I just want to just remind you that it's important to take care of yourself. Take care of not just your physical health, but your mental health, and find things that bring you some joy. I love this photograph of these 2 little boys skating. I really enjoyed seeing the kids last week. I really enjoyed seeing the kids last week skating on Lake Chippewa. Just getting out there and getting into nature and enjoying the fresh air. If you like music, I find I'm playing more music now. I just find it more relaxing. And it's important to find reasons to smile. We have to find reasons to laugh. And the slide on the bottom is a little Palestinian boy who didn't have any access to a face mask. So he constructed a mask using a cabbage leaf. Probably not very effective, but it made everyone smile. And we got to do that. So welcome to the Varasphere. Where's the viruses? Well, this is Lake Huron. A place I love to spend time swimming in the summertime. Actually, the lake is full of microbes. Millions, billions of viruses and bacteria, but they're meant to be there. These are healthy microbes that help to keep the lake in a healthy balance. The only problem is if humans spill, farm runoff or septic tank runoff into the lake, then people can get sick. But the natural microbes that are in the lake are there for a reason, and it's to keep the lake healthy. So what about us as humans? Well, the microbiome is what we call all the microbes that are in and on our body. So just consider that your body has 30 trillion human cells. Did you know that your body has actually more microbial cells than human cells? It's an estimated 39 trillion microbial cells made up of bacteria, yeast, fungi, archaea, protists, and viruses living in and on our bodies. Protists are like single cell parasites. Archaea are similar to bacteria, but they're sufficiently different biologically to be put into a separate domain. You can find archaea up your nose and your nostrils. We don't really know what they do, but that's where they live. But the important thing is that all these microbes are there to keep us healthy. They're not there to harm us, and we can't live without them. And we're finding out more and more about how they keep us healthy. And we know that it's not just keeping us healthy physically, but helping us keep mentally healthy as well. So this is a fascinating topic. It's a topic for a separate presentation, so I'll just leave it at that. But we are not alone. If you want to look at my face now and imagine a square centimeter of my face, just a small square centimeter, there's 1 billion microbes in that square centimeter. So just imagine my whole face covered with billions of microbes. And next time you go into the bathroom, have a look at your own face in the mirror and try to imagine all the microbes on your skin. When a baby is born, the first gift it gets from its mother is microbes. It gets tons, and well, not tons, but billions of healthy bacteria that get the baby off to a good, healthy start. In the first baby stool, the meconium, you don't really find any viruses, but by the time a baby is a month old, you'll find about 1 billion viruses in a gram of its stool. And we don't really know what most of those viruses are doing, but we know that most of them are called bacteriophages. So most of the viruses in our gut are bacteriophages. And here you can see a bunch of bacteriophages attacking a bacterium, because that's what they do. The name really means to eat bacteria. They kill. They're bacteria killers or viral assassins. And we think that what they do is they help to keep the bacteria in our gut in balance. So they're selectively killing bacteria here and there so that no bacteria gets out of balance and causes problems. So they look like little lunar landing modules. So that's just another interesting morphology that viruses have. Bacteriophages are being researched for other fascinating reasons. This is a little slide to let you know that not all viruses are bad. We're now genetically modifying them to help cure diseases. The bacteriophages, you may have heard of phage therapy, which is not new, but phages can kill bacteria, and we think that these might become very useful in treating bacterial infections that have become resistant to antibiotics. So there's a lot of research going into that now because antibiotic resistance in bacteria is becoming a huge public health crisis. Bacteriophages are also being researched to kill tumor cells. So if we can genetically engineer bacteriophages to get into inoperable cancers, and they can inject genes into the tumor cells that will instruct the tumor cells to make proteins or toxins that will kill the tumors. So this is a very exciting area of research. And on the bottom here, we have a cold sore virus, a herpes virus. And this has been genetically engineered already to treat malignant melanoma, terminal melanoma. Genetically engineered herpes viruses can be injected into the melanoma to kill the tumor cells. So lots of exciting research going on. So a single virus is known as a virion. I love the simple definition. It's a piece of bad news wrapped in protein. So this is a cross-section of an influenza virus. The bad news is the spirals of RNA inside. Viruses are either made of DNA or RNA, deoxyribonucleic acid or ribonucleic acid. The genes, the RNA, is surrounded by a protein coat, and the protein coat is surrounded by a lipid envelope. So that's really all it's composed of. And then you have these protein spikes. And I think we all know, we've all heard of protein spikes on the coronavirus. Well, the influenza virus has its own protein spikes that help it to attach to cells and break into the cells to infect us. So it's important to realize how small viruses are. If you look at the slide rule here, you can see 1 inch on the top, and then on the bottom you can see centimeters. 1 centimeter is divided into 10 millimeters. So we need to divide millimeters into 1,000 parts to create microns. And microns are how we measure bacteria. But we can see bacteria under a microscope, but we can't see viruses under a microscope because they're much smaller than bacteria. So we need something smaller than microns to measure viruses. So we have to take 1 micron and divide it into 1,000 more parts. And we call those nanometers. And that's how we measure viruses. So really, really small. We can't see them with microscopes. You need an electron microscope to see a virus, which I'll talk about in a few minutes. And here's an example of an adenovirus. It's about 80 nanometers, very, very small. Again, you can see it looks totally different from Ebola and influenza. It's a very geometrically shaped little virus. And this is the virus that is actually being used in the AstraZeneca vaccine and the Johnson & Johnson vaccine to carry the coronavirus RNA into our bodies. So I'll say a little bit more about that later too. So just to get you thinking about the size of virus, how many viruses do you think would fit on the head of this pin? This is just a little tailor's pin, a sewing pin that holds, you know, your shirt together when you buy it. You take them out, just a small little pin. How many coronaviruses do you think would fit on top of that pin, the head of the pin? Would it be 5 million? Would it be 25 million? Would it be 100 million? The answer is 100 million. 100 million viruses on the head of a pin. So that gives you an idea of how incredibly tiny these things are. Okay, we all know about the Spanish flu pandemic, 1918-19, killed from 40 to 60 million people. And remember that the population of the world back then was only 1.8 million, billion, 1.8 billion, less than 2 billion people. Today, it's almost 8 billion people. So it still managed to kill millions of people. The slide on the right there is a little community of Inuit people in Labrador that was taken in 1908. When the Spanish flu hit Labrador, this community was basically wiped out. just like the coronavirus, indigenous peoples seem to be more susceptible to certain viruses. And of course, we know that the history of the Americas is a history of epidemics which wiped out most of the indigenous peoples. So the Spanish flu pandemic was H1n1. We call it a swine flu pandemic. It didn't come from Spain. We don't really know where it came from, but the latest thinking is it probably came from China. We had another H1n1 swine flu pandemic in 1977. I know because I was a victim. I was very ill. I was 27 years old. And this is what happens with H1n1 pandemics. It tends to hit younger people very hard. And I was so sick, I couldn't get out of bed. If I tried to go to the bathroom, I would just collapse. My muscles were just gone. So it killed, I think, about 750,000 people. And it probably came from China, even though it was called Russian flu. And then in 2009, there was another pandemic. You may remember this one. By 2009, we stopped giving countries names to pandemics because we were concerned about racism. We all know that's happened. So the H1n1 pandemic in 2009, the World Health Organization did actually declare this an official pandemic. And then it was highly criticized for doing that because the mortality was actually quite low. It only killed probably about 600, maximum 600,000 people, which is low for a flu pandemic. And that one originated in Mexico from a pig farm. So these are all swine flus because they all originate in pigs. So why do so many influenza pandemics or flu outbreaks come from China? The main reason is that there's a lot of waterfowl in China that migrate up to Siberia. And on their migration route, they pass over lots of pig farms in China. Chinese people love their pork. And most of these pig farms are outdoors. So they get contaminated with the poop from the migrating birds. Migrating waterfowl are natural hosts of influenza viruses. That's where they come from. And so the pigs get infected from the waterfowl, and then the viruses mutate inside the pigs, and then they can be transmitted to farm workers. And from there, they can spread out into a pandemic. Just as a matter of interest, last January, Dorothy and I were very sick as well from the flu. There was 4 viruses last winter. A lot of people were sick. It was a really bad flu season. And some of that was H1n1. And some of it was H3N2. H3N2 is a more traditional flu virus that hits the over 65, so we could have been infected by that. But H1n1 tends to go for the younger groups, younger age groups. And I know that in 2009, I knew several young people that were very ill. So the big fear now is avian flu. There's been a number of bird flus infect farm workers in different countries and kill farm workers and people in close proximity to these factory farms. The latest one is H5N8, and Russia has just reported 7 human cases in December. So the fear is that these bird flus, although they can cause illness in humans who are working closely with the chickens, the big fear is that one of these avian flu viruses will become a pandemic strain and cause the next major pandemic. And if there's an avian flu pandemic, it will make this present pandemic look pretty tame by comparison. because avian flu has a mortality rate of about 30%. 30%. It'll cause mass deaths all around the world. So until we can get a universal flu vaccine, we have to be concerned about avian flu. This is another virus that hits children pretty hard. Respiratory syncytial virus, kills about 60,000 children and also about 4,000 seniors per year. So globally, that's not a high number, but there's currently a vaccine in production or in development by Moderna and also Johnson & Johnson. My son had an RSV infection when he was 1 year old. He had trouble breathing. We took him into hospital. He was hospitalized overnight, and he was okay the next day. But small babies can suffer serious respiratory distress from this virus. And many children who are infected go on to develop asthma. So developing a vaccine against this virus will be a good thing. One of the greatest killers, one of the biggest killers in history is smallpox. There's an old German proverb that says, "From love and smallpox, few remain free." It's one of the biggest killers in human history. It's now eradicated due to vaccination. The last case was in Somalia in 1977, and the World Health Organization declared the world free of smallpox in 1979. But even in the 20th century, 300 million people died from smallpox. It's a horrible, horrible disease. It can kill 1 in 3 people. Those who survive are left with permanent scarring and often blindness. The photograph here is from 1962. It's from a little town in Wales called Fernville. There was an outbreak of smallpox in Britain in 1962. And you can see the people all lined up here to get their smallpox vaccination. Everyone in the town wanted vaccinated because everyone knew how deadly smallpox can be. As I mentioned earlier, smallpox was also one of the greatest killers of the indigenous peoples in the Americas. We have had a vaccine against smallpox since 1796, when the English doctor Edward Jenner developed the smallpox vaccine. And this is a quote from the Iroquois Confederacy: "We shall not fail to teach our children to speak the name of Jenner and to thank the Great Spirit for bestowing upon him so much wisdom and so much benevolence." Because without vaccination, even more indigenous peoples would have died. We're now in the COVID-19 pandemic. It probably came from a wet market in China, from bats into people or into another animal, which then infected people. On the right here is the capital of Brazil, and you can see all the mass graves that are being built outside the city to bury the victims of COVID-19. This is the scientist who discovered coronavirus, the very first coronavirus. Her name was, I realize I'm getting a bit short of time here, but her name was June Hart, who is a Scottish lab technician. And she became very expert at using the electron microscope. We need electron microscopes to see viruses because light microscopes just aren't powerful enough. And June Almeida, which was her married name, discovered the first coronavirus, and you can see what she saw on the right there. She found it causing a common cold in a little boy in England. And it was given the name coronavirus because it reminded scientists of the corona in a solar eclipse. The halo, corona meaning crown. Just some other weird viruses. HIV. HIV is another pandemic virus. It came along in 1980, and it took about 2 or 3 years to find out what the cause of AIDS was. Very difficult virus to detect. They eventually found it. The founder got the Nobel Prize. But the interesting thing about HIV is we still don't have a vaccine. We probably will have a vaccine in the near future, but even after 40 years, it's still not there yet. Hepatitis B, Ebola, bacteriophage, influenza, adenovirus. So if you get the AstraZeneca virus or the Johnson & Johnson virus, they're made from adenoviruses. They're genetically engineered adenoviruses to carry the coronavirus into your body so that your body will then produce spike proteins of the coronavirus, and then you will develop immunity to those spike proteins. So when you get the AstraZeneca vaccine or the Johnson & Johnson vaccine, you'll actually be getting injected with millions of adenoviruses. The AstraZeneca virus uses a chimpanzee adenovirus, which is harmless to humans. It's only going to carry the RNA into your body so that you can develop immunity, so you don't have to fear it. One of the most deadly diseases in the world still is measles. We need to make sure everyone is vaccinated against measles because it's one of the most infectious diseases on the planet. And in order to acquire herd immunity, you need to have 95% of people in your community vaccinated. And because of vaccine hesitancy, people not getting their children vaccinated, or inability to access a vaccine in the third world, we're seeing tragic deaths of measles still in the world. Last year, over 200,000 people, mainly children, died of measles. So we really have to do something about this reluctance of parents to vaccinate their children, because there could be an epidemic of measles happen here too. The World Health Organization lists its top global health threats at the beginning of every year. The #1 health threat, air pollution and climate change. Climate change is causing the spread of infectious diseases, and air pollution increases people's susceptibility to disease by weakening your immune system. Global influenza pandemic, I mentioned that earlier. The big fear is mainly an avian flu, bird flu, which can kill hundreds of millions of people. We're still under threat from more coronaviruses and other diseases we haven't discovered yet. So just to give you an example of a local emerging disease due to climate change, it's not a viral disease, it's a bacterial disease transmitted by these black-legged ticks. And of course, you probably know about Lyme disease. So Lyme disease has become very common in this area and all across Eastern Canada. And it didn't basically exist here in Sarnia when I first came. And it's thought to be due to climate change, the mild winters, which are causing the explosion of growth of these ticks that carry the bacteria. Another reason we're getting more epidemics and pandemics is deforestation. We're cutting down forests, not just in the Congo Basin here, but the Amazon and even in Canada. All over the world, forests are being decimated. And people are being exposed to diseases carried by bats and rodents and monkeys and other primates that we normally wouldn't be exposed to. So that's a big concern. This is one example of an epidemic caused by a virus, the Hepa Virus, which was first discovered in 1999 in Malaysia, has 50 to 75% mortality. It's caused by people going into the forests, being exposed to fruit bats, or else the fruit bats dropping fruit into pig pens. The pigs eat the fruit, get infected by the virus, and then pass the virus on to farm workers and also abattoir workers, who then get infected and then they can spread the virus to other people. There's been a number of outbreaks of Hepa Virus in several countries since 1991, and it's killed tens of thousands of people. It was the inspiration for the movie Contagion. It wasn't called Hepa Virus in the movie, but it was the inspiration for making that movie Contagion. If you haven't seen it, it's a pretty scary movie. So we know that industrial farming and slaughter of animals is creating a perfect storm for the next pandemic. I talked about avian flu, I talked about swine flu. That's where these big pandemic viruses first hatch, first mutate. And animals kept in inhumane conditions like factory farms are under stress. Their immune systems are suppressed. They become more susceptible to viral infections. The viruses are better able to mutate, then they're better able to transmit to humans. So we need to find ways to stop factory farming and stop wet markets in China and other countries, because we're setting ourselves up for the next pandemic. Okay, how can we do that? How can we get rid of factory farms? Well, we can't all become vegetarians. That's not going to happen, although it'll be a help. But we could close all the factory farms and start growing our meat in factories. That might sound like Frankenstein to you, but if you think about it, it makes a lot of sense, and it's already being done. There's a plant in Denmark that's producing this cell-based meat. It doesn't look very appetizing in a Petri dish, but these chicken McNuggets on the right-hand side have been made by a 3D printer, and this could be the future of food. I'm really excited about this, I really am, because think of the benefits of cell-based meat. We reduce the chances of pandemics. We reduce deforestation because a lot of forest is cut down to create farmland for animals to graze on. We reduce that biodiversity loss if we are not deforesting the world. We are reducing our greenhouse gas emissions if we can eliminate factory farming. We can reduce morbidity and mortality from foodborne illnesses because a lot of food poisoning comes from animals or vegetables and fruit contaminated by animals. We can eliminate animal suffering, and we can eliminate animal epidemics. What's an example of an animal epidemic? African swine fever. Oops. African swine fever is causing havoc in pigs in China, Vietnam, and other countries. It's spreading up into Eastern Europe and is spreading to other countries. It's decimating the pork industry, and millions upon millions of pigs have to be culled. The good news is that it'll probably not mutate into a pandemic form, but it's decimating economies. And the slide on the bottom right is the border of Germany and Poland. Germany is erecting these fences to try and keep out wild boars who are carrying the virus from Poland. They don't want this virus into Germany because they don't want their pork industry decimated. So it's driving up the cost of food as well everywhere worldwide. So get rid of factory farming. We need to create a new vision. The old world is broken. We need to green our cities. This is an artist's conception of the Champs-Élysées in Paris. They want to transform it into a pedestrian oasis. We need to get rid of carbon-based fuels. This is an airplane run by hydrogen. We just need to do what we need to do to address climate change and stop pandemics. Just to finish off very quickly, astronauts who go into space, they go up into the space station. A lot of astronauts, when they come back to Earth, they are transformed. I mean transformed in a profound way. They see the world through totally new eyes. The indigenous peoples refer to it as two-eyed seeing approach. Astronauts are trained in science and engineering, but when they come back to Earth, it's as if they have fallen in love with the earth. They say it's an incredible spiritual feeling that lasts for, unfortunately, just a few days. They fall in love with the earth, and that's something that we all as a species have to learn to do, because we have forgotten how to love this planet. The future is not some place we go to, it is what we choose to create. So sorry, didn't realize that was going to take me so long. We do have time for questions, I hope. Paul, do you have anything in the chat? Oh, yes, you do.
Yes, yeah, we've got quite a few questions, and yeah, we've got lots of questions, and we don't have a lot of time, but can't get the questions. Okay.
That was a lot of information. So.
Yeah, but it looked like lots of people were enjoying it because no one left. I was looking at the numbers on the screen and everyone seemed, so I'm going to try and pick some of the key questions so we can, so you can spend some time on those. It says, how long until you think cell-based meats become an option that is accessible in mainstream?
Yeah, as I say, I'm already aware of a plant in Denmark that is making this cell-based meat. You know, obviously it's a big challenge, but I think we're going to get there. With 3D printers now, we can grow the cells and then we can transform them into looking like chicken McNuggets or steak. The challenge with, say, a cell-based steak is what about the flavor? Most of the flavor from a steak comes from the blood that is in the steak. So there's lots of little issues that have to be addressed. You know, so realistically, we're not going to turn everyone into a vegetarian. That might be the ideal scenario. So cell-based meat, I think, is a great option. So I'm excited about it. I think it's going to happen, but it's not going to be for a while.
Okay. Another question here is, can you speak about herd immunity?
Herd immunity, well, as I say, you always need to get a certain level of immunity to stop a virus from spreading or any disease from spreading in a community. I mentioned measles is one of the most infectious diseases on the planet. So you have to have a very high level of immunity. And when you don't have that, it creates an opportunity for the virus then to break out again and cause problems. The Toronto Star actually this week has a site on its website. And if you have a subscription to the Toronto Star, you can go onto the website and you can type in the name of any school in Ontario, and it will tell you the percentage of students who are up to date with their measles vaccinations. And I just checked this last night, and Sarnia Lambton, we're doing great. We have 95% compliance in Sarnia Lambton, but there's some schools in Ontario that are really low. And, you know, we're just playing with fire. And this vaccine hesitancy thing is a big concern.
Great. There's so many questions. I'm just trying to pick a few. Can we draw any direct correlations between the emergence of these serious viruses and the degradation of our climate?
Yeah, well, the connection is what I tried to explain in some of the slides. You know, people started getting Ebola in the 1980s because people were deforesting the land, and they're also going into the forests to kill monkeys for meat. So you're exposing yourself to wild animals. The same in China, where a lot of Chinese people are exposed on a regular basis to bats. They live close to bat caves, and those bats are close to their farms. And so it's the closer we get to wildlife, the greater risk there is of acquiring the viruses. So that's really the connection. I didn't get a chance to talk about how we can take measures to maybe detect some of these viruses. in advance so that we can have an early warning system. And that is underway. There are a number of projects that are trying to find these potentially deadly viruses so that we can prepare for them if they break out, and we can have vaccines and treatments ready. But we need to do a lot more, putting a lot more serious money into this kind of research.
Yeah, that leads to a question. It says, will we be better prepared to deal with the next pandemic from lessons learned?
Yeah. I mean, it's just incredible how fast we've been able to get vaccines for this disease. This is I would call it a scientific miracle. No vaccine has ever been produced this fast, and it's not just one vaccine, but several vaccines, and they all seem to be very highly effective. So now we have this technology where we can rapidly produce vaccines. We know how to do it now. So it's just a matter of sequencing the genome of the virus and then custom designing a vaccine that will do what we want it to do. So we're incredibly lucky that we've been able to do this for this coronavirus.
Okay. Another question here says, why are they called coronaviruses?
I tried to address that as well when the electron microscopist June Almeida first saw the virus. The early electron microscopes didn't have very clear images, but it looked like it was surrounded by a bright halo, which reminded scientists of the corona of a full solar eclipse rather. And corona means crown, so it was like the crown of the solar eclipse.
Okay. It says, does cooking food properly kill viruses?
Yeah, cooking food properly should kill all microbes. Yeah, so make sure your food is properly cooked. That's the short answer.
Okay. A question, it says 60 to 65 years ago, almost everyone I played with got measles, and I do not recall anyone dying. I believe there are two types of measles, red and German, which are more deadly.
Yeah, they're two totally different diseases. German measles is rubella. It was mainly a concern for pregnant women who could transmit the virus to their unborn child, and the baby could be born either dead or deaf or other serious neurological abnormalities. So it was very important to develop a vaccine against German measles or rubella. Yeah, red measles, you're right. I had red measles myself. Most children will recover from red measles, but not everyone. It can cause pneumonia. It can cause encephalitis. It can kill. I remember Roald Dahl, the children's author, his young daughter died of measles, and he wrote one of his books in her memory. So it can kill, but it is more deadly in developing countries where children are malnourished, and that's where we're seeing the majority of deaths today. The other interesting thing about measles is that scientists think that it also suppresses your immune system, especially in malnourished children. So even though you may recover from measles, your immune system can suffer serious damage to the point that you become more susceptible to other infectious diseases. So it can be a real nasty virus.
And I have probably time for one more question. It says, if someone develops natural immunity to a childhood viral illness, do they have a decreased cancer risk?
Decreased cancer risk? No, I don't think so. I haven't heard that before. Some viruses can cause cancer, but no, I don't think viral immunity will give you any guarantee.
And one final one here, maybe. How does pollution affect immunity on a physiological level?
How does pollution?
Yeah, how does pollution affect immunity on a physiological level?
Well, air pollution, we know, is very harmful in a number of ways to us. You know, it causes, the particles in air pollution can cause a lot of inflammation in our bodies. and that can set us up for increased risks of heart disease and stroke. But it can also damage our immune system as well. Not exactly sure, how it does that, but anytime you have increased inflammation, you're priming your immune system to do something that you really don't want it to do. So I think that this is an area of increased research. I know I read that in northern Italy, where the first COVID cases occurred, northern Italy, there is a lot of industry around there. There's a lot of air pollution. And some scientists have speculated that the mortality rate was higher there than other parts of Italy because of the air pollution. So we know the World Health Organization is telling us that 90% of people today are exposed to air pollution, and that it is killing a lot of people every year in various ways.
Okay, we're out of time. I think you've done a fantastic job, Allan. And I don't know if anyone has anything else. Yeah.
No, I'm just giving a thumbs up to John Rowe there. I haven't seen John for a while. He's an old buddy in Woodstock. He's originally from Dublin. He used to be a medical rep for Becton Dickinson. He used to come into the lab and see me all the time. So hi, John. Some other old lab colleagues there. Good to see you all. Yeah. Maybe, if anyone would like to email me your question that I didn't answer tonight, if you can provide my email, Paul, I'd be more than happy to address your questions.
Okay. And just to let people know that next month we will have another speaker. It's Ed Brost, and he's going to be talking about the hydrogen economy, which I've heard some rumblings in terms of Sarnia could become a center for hydrogen production. So that should be very interesting. So thank you once again, Allan.
Thanks, Paul. Thanks, everybody. Thanks for joining us.